So we have to give ancient people some credit. They did a pretty good job naming the planets. For example, Mercury is the messenger god, sometimes depicted as like a little guy with wings on his feet. Think of like the symbol for FTD florist and shoe stores and things like that. Because Mercury literally moves fast in the sky. So they named it the messenger god for that reason. Of course, it moves fast because it's close to the sun. And gravity, that force there, that centripetal force, swings it around at a fast rate. Anyway, Mercury is a terrible object for viewing, to be honest, for lots of reasons. It's a small planet, so it's going to be small in your backyard telescope. It's a dark planet. It doesn't reflect light very well. And it doesn't have any major features that you can see with a backyard telescope. I mean, even a really good backyard telescope. It doesn't have like, Saturn's rings or Jupiter's stripes or moons and things like that. But there's another problem. Mercury hangs out by the sun. This is a problem. The most it can ever be away from the sun is 28 degrees. Now think about what that means. First of all, it means that you only can see it either right before sunrise or right after sunset. That's it. You can't see it, for example, late at night, 10 o'clock, 11 o'clock, midnight, because at those times the Earth has spun away from the sun. Therefore, we've spun away from Mercury, you understand? So it's not there. So you can't see it late at night when it's nice and dark. And this is important, you can't see it high in the sky. You're never going to look up at your zenith and see Mercury there. No, at most, again, if you think of 90 degrees like this and 45 degrees, and now you're down to like 28 degrees, now you're running into problems. First of all, the blurriness of the atmosphere. And then at some point you're going to have things in the way like trees and houses and things like that. So Mercury is always going to be fairly low in the sky. And then let's take a look at this graphic here to explain some other problems. See, first of all, when Mercury is anywhere in this area over here, you're not going to see it because the sun's in the way. And when Mercury's right in here at its closest, guess what? You're not going to see it then. Because when we turn towards it then, we're also turning towards the sun. That's called daytime. So you can't see it there, you can't see it there. The only times you see it are kind of at these weird side angles like here and here. And so of a 365-day year, you only get to see Mercury possibly 50 days a year. Half the time you can see it in the evening, and the other half of the time you can see it in the morning. And by the way, ancient cultures often called it two different things. They had two different names for it because they thought it was two different objects. And of course, we know that it's just the same planet, Mercury. So, and that 28 degrees is at its very, very best. Sometimes it's not even that good, as you can see in the picture in the right. So, only at dusk or dawn, and only 50 days out of the year, if the weather's good and all that. Okay, a couple important vocabulary terms here. When things are lined up in the sky, we call it a conjunction. So for Mercury, and this is actually, I think, a graphic of Venus, but it works the same way. When Mercury is at inferior conjunction, it's Earth, Mercury, and the Sun lined up there with Mercury in the middle. That's inferior conjunction. And when it's Earth, let me see if my cursor is working here, Earth, Sun, Mercury, with the Sun in the middle, it's at superior conjunction. So that means the Sun and Mercury are lined up in the sky. But in both cases, that's a problem. So at inferior conjunction, it's daytime. At superior conjunction, the sun is right in the way. And that's a shame because at superior conjunction, that's when we would see the full face of Mercury. It'd be kind of like a full moon. You'd see the full face of it. We never get to see the full face of it for that reason. So if it didn't have enough problems already, look, when we're looking from this direction from the Earth, half of it's in shadow. So at the very, very, very best, you can see half of Mercury. It would look, again, like a quarter moon, like a first quarter or third quarter moon. You're seeing half of the face of it. Oh, and one other problem I didn't address. You live on a planet that spins 360 degrees in 24 hours. 360 divided by 24 is 15. So the Earth's spinning 15 degrees per hour. So when Mercury, if the sun sets and Mercury's almost 30 degrees above the horizon, remember, that's at its very best. If it's about 30 degrees above the horizon, guess what? You only have a couple hours to see it. And that's right after sunset, so it's still light out. It's not a really good time to do astronomy. And so again, that's why you're not going to see it out late at night when it's nice and dark at 10 o'clock, 11 o'clock, midnight. Mercury's not going to be there anymore. Anyway, or you have 2 hours before sunrise, if you want to look at it that way. And that's, at the very best. So what does it look like? Here's just a picture of what it might look like in the sky. Very rare occasion do I ever see it at our astronomy nights and point it out. But, I don't go out looking for it intentionally. But on a rare occasion, if we see it, I point it out, of course, to my students. Now, I will say this. About once a decade, Mercury's pretty darn cool. That's it. About once a decade. In the 20 years I've been teaching astronomy, twice I've seen it where I thought, all right, that is pretty cool. And the first time, I don't remember what year this was, actually. It's been quite a while ago. Was a transit. We had our first telescope for my class, and we bought our first solar filter, and we took this picture from the courtyard of Marjory Stoneman Douglas High School. And there's the sun, of course, with this filter. On the right, you see a typical sunspot. We'll get to those later. It's kind of a cool spot, a relatively cool spot on the sun. And then over on the left, there it was, little Mercury crossing the sun. It took several hours. All my classes went outside one after the other to see it during the day, and I got to kind of see how it slowly made its way across the sun. It took several hours. And then just a few years ago, in 2015, it happened again. This time happened to be a employee planning day, so there were no students at school, and the teachers were out in the courtyard, and got to see it, another sunspot there that time as well. So that's called a transit. Of course, NASA takes their own pictures. I guess theirs are okay. They try. Yeah, pretty neat shot there. Okay. Kind of a unique geological feature of Mercury is something called a scarp. A scarp, you see these weird wrinkles in the surface of Mercury. Now, right down here in this picture, let me see if my cursor, here we go. That wrinkle in the surface, if I saw that in a satellite image of the Earth, I would, of course, think that was a fault line, like the San Andreas Fault or something, right? Where plates are coming together or splitting apart or going under each other or whatever. Here's a problem. Mercury doesn't have plate tectonics. So that can't be the solution. So where are these weird wrinkles coming from? Well, scientists speculate that Mercury, early on, when it was molten and cooled off, the entire planet shrank. And it kind of crumpled up a bit as it shrank. So my analogy for this is a grape becoming a raisin. And you get that crinkled surface, that wrinkled surface. So anyway, kind of an interesting idea there for where Mercury got its scarps. And you can see here why we put Mercury and the moon in the same chapter together. They look awful lot alike. They have their major differences, though. Here could be a very major difference if this is proven, that Mercury might still have some geological activity. In other words, it has magma. We know that deep inside it still has some magma somewhere. It's still molten somewhere, but on the surface, that's another story. I don't think that's been proven yet, but it's very possible that it's still active. You could still have Mercury quakes, for example. Okay, this is a picture from the 1970s. The first time we sent any spacecraft, let me think. I think it was a Mariner 10 spacecraft on a flyby of Mercury. That's all they did. They flew by, and as they fly by, they can only photograph half the planet. So it's kind of embarrassing. For the first decade that I taught this class, I had to tell the kids, we've only photographed half of the planet Mercury. And one of those pictures showed this giant crater that we call the Caloris Basin. When a crater gets big enough, I forget how many exact miles it is, but at some point they start calling a crater a basin. Same thing, though. It's like a tall hill versus a small mountain or whatever. just semantics there. But anyway, Caloris Basin is the site of a truly monumental impact. So monumental that it actually answered a bit of a mystery they had. They found this very strange looking region on Mercury. It had this jumbled, weird terrain. We literally call it, this is the actual name, weird terrain. Well, it turns out that terrain happens to be exactly 180 degrees opposite from the Caloris Basin. So the theory is that that impact was so huge that shock waves rippled around the planet, met up on the opposite side of the planet, and jacked up that side of the planet and created all this weird terrain. So that's a pretty neat idea there. That seems to make sense as to what caused such strange geological features on the opposite side of Mercury. So that's pretty cool. That's about the only feature on Mercury that I have my students learn is the Caloris Basin. Okay, there's a little bit of that weird terrain at the bottom right. So finally we went back to Mercury, and Messenger arrived in 2008, did a flyby, and then went inserted into orbit around 2011. Took this beautiful shot of a crescent Earth as it left the Earth. So Messenger's been our main mission to go to Mercury, and took some amazing pictures like this one. Obviously a very battered world. Those craters are huge, and these stripes that you see coming off of the craters, they're called the Ejecta, or the Ejecta blanket, and they go for hundreds of miles, it looks like, and there's nothing there to erase them. So in the whole history of Mercury, as it's been battered, mostly very early in its history, there's nothing there to erase. There's no water and wind and lava and plants and animals and people, so we still see that battered surface today, and very ancient surface. Mercury has had some surprises over the years. One surprise is that it has a magnetic field. You see, usually you have to have a pretty big sized planet, fairly good sized planet, to have a magnetic field, because small things like asteroids and moons usually have cooled off enough that they don't have any molten material. Just like a small cup of coffee cools off before a large cup of coffee. Well, Mercury's a pretty darn small cup of coffee, so they thought it just cooled off and it was a dead little world. But apparently it has some molten material sloshing around in there because it has a magnetic field. That was very surprising. It's not a strong magnetic field, but they still didn't expect a small planet, especially one that rotates slowly. That's the other big factor. You want a planet to spin quickly. So you have a small planet that spins slowly. That doesn't seem to make sense. But it must have a molten core to have this magnetic field. So what's the solution? Well, it appears that Mercury has a pretty good sized core. For the size of the planet, it's actually the largest core in the solar system. Now remember, it's not even close to being the actual largest core. It's just that relative to the size of the planet. For example, the Earth's core makes up about 15% of Earth by volume. Same thing with Saturn and so forth. But with Mercury, it's 40% of the planet. So it's kind of behaving like a larger planet in a sense. It's behaving more like its sister planets, Venus and Earth, and in terms of having that larger core. So good for Mercury. It has a little magnetic field. Gravity-wise, it's 38% of our gravity. So if you could dunk on a 10-foot goal on Earth, theoretically, you could dunk on a 26-foot goal there. One other big surprise I want to get to here. Actually, one other kind of fun fact. It sure looks like Mercury should be tidally locked with the sun, that it should be dominated by the sun, where one face is always towards the sun. And to our surprise, it was not. That was confirmed by the Arecibo dish, the big radio dish in 1965. Possibly because its orbit is a little more eccentric, a little more stretched out, and that change in rate may have saved it from becoming tidally locked. So it's kind of interesting. That's another little surprise. Mercury's full of surprises, really. It rotates very slowly. Almost 2 Earth months go by the time it's rotated once. Now, Mercury only has an 88-day year, and it takes 59 days to rotate on its axis. Yeah, it's kind of crazy. So it has what we call a 3-to-2 spin-orbit resonance. It spins 3 times for every 2 orbits it makes around the sun. It spins 3 times on its axis in the time that it goes around the sun twice. So 3 spins in 2 years. But here's where things get weird. And I remember it. I tell my students to remember it as 3, 2, 1. I'm going to have to get into this more. We're kind of running out of time here. I'm going to finish this up in another lecture. Thanks for listening.